Okay, this is Mr. Weideman, AP Physics, another UT Quest problem on simple harmonic motion by popular request. A harmonic oscillator, it is in oscillation and a bullet hits the oscillator right at the neutral point. It's right passing at the neutral point. Okay, so the bullet hadn't hit yet. I'm at the neutral point. What's the velocity? Okay, so this one, we know how to do this. All right, so I'm just going to use conservation of energy. The bullet hadn't hit the block yet, so I just need to go V max. I'm given the amplitude, so I can find the total energy of the system. Yeah, pretty straightforward. Okay, so I'm going to need this V max for my next part of the problem, because what's going to happen next is this block is in its oscillation. It says it's moving from left to right. So right at the neutral point, this Vm2 is its maximum velocity, and it's going from left to right. Okay, now the bullet is also going left to right, but much faster. It impacts and it embeds. So what we have to do now is I need to do a conservation of momentum problem for a completely inelastic collision. And we have the setup for that. All right, so we know all this stuff. This variable right here is what we just finished solving for, right there. So then that makes this happen. So we can solve for that guy. All right, so what I have now is I have a new V final. And what am I supposed to do with that? I need a new amplitude. Okay, now I could use my kinematics equations to do that, and that would not be any fun. However, if I decide to use conservation of energy, this is going to be a simple plug and chug. I have my new velocity, I have my new kinetic energy, I'm still at the neutral point, so that is then going to allow me to find out what my new amplitude is, because all that kinetic energy is going to turn into spring energy. Okay, now what is the final part of this? Okay, the final part of this has to do with the period. And the impact of the bullet, yes, it adds more energy. Yes, it's going to change the amplitude. I don't care about that, all right? That amplitude is not going to help me. What it does do is it's going to change the period, not because it added energy, but because it added inertia onto the mass. All right, but I know all this stuff, so I can calculate my new time period. Okay, now that time period is for an entire oscillation. What the problem wants, it just wants the amount of time to go from impact, which occurs at the neutral point, all the way to its new amplitude. Don't need to know where that new amplitude is. All I know that motion takes 1/4 of the cycle to accomplish. So I know the period, I know it takes 1/4 of that period to go from neutral point to one of the amplitudes. And so that's the way you do that. I didn't even try the kinematics approach on part 2. So if you hate yourself, you can try doing that. And good luck. All right.